right, so exercise 549. Sorry, I'm moving things around. 549. This is the one we did the second part of it. We didn't do the first one. So again, all of the content has been removed. We can see all those four things I talked about. We have our mean. We don't have a standard deviation in this case. We have a percentage, a direction for that percentage, and a cutoff. So we've got everything we need to answer this question. First thing we want to do is draw our curve. We know the mean is 20. We're talking about 22 above tells me we're shading the right-hand side, and we know 25% is above that. So we've got our whole drawing, and we're trying to find our standard deviation. So in order to do this, remember this is still that two-step process. First step, we need a z-score to use in either of the two formulas. In order to get our z-score, we're going to do inverse norm, and we're going to use our percentage. So if 25% is on the right-hand side of our curve, that means 75% is on the left-hand side. And inverse norm needs a left side probability, so we got to give it 0.75. We can also see here that our cutoff is positive, so it should be above the mean. So if I were to pull up my little calculator, which is very small right now, pull up my calculator. No! All right, I got it back. If we're going to pull up our calculator and do our inverse norm, we can just type in 0.75 if we have the older calculator. If we have a newer calculator, remember the mean and standard deviation for a z-score are 0 and 1. So that's what you'd be typing in for your mean and your standard deviation. Since I turned off my stats wizard, I have it easy. I can see that my z-score is a positive 0.6745. 0.6745. So our 22 is not very far above the mean, which makes sense with the fact that we have such a large percentage to the right of it. Step 2, we can use whichever formula we want. As I said, I like to use, in the normal section, the inverse formula. I just feel like it has less chance for error. So I'm going to use that formula. So x is equal to z times our sigma plus mu. This is basically saying this 22 is this many standard deviations away from the mean, right? It all makes sense with our z-score. So our 22 is, 0.6745 standard deviations away from the mean. So the difference between our cutoff and our mean is a 2. And the question is, if that is 0.76 standard deviations, we can figure out exactly how large a standard deviation must be in this particular example. So I can pull back up my calculator, do 2 divided by 0.6745. Looks like our sigma is 296.52. I say these things out loud, mostly for my own benefit, because otherwise I cannot remember them once that calculator goes away. So anyways, that's finding a standard deviation when we have the mean and our area under the curve for a particular cutoff. We also did finding a mean when we have this standard deviation and the area under the curve for a cutoff. So we've seen every single way that these questions can go.